The second piece of the puzzle is understanding the heat transfer mechanisms and especially how they are established inside different regions of the boiler. For heat flow, which is the flow of thermal energy due to temperature difference, where the governing equation becomes heat flow equals delta T divided by R thermal, where R thermal is the resistance offered to the flow of heat. The aim for a boiler is to make sure that this thermal resistance is as small as possible. Heat can be transferred through three separate modes: conduction, convection, and radiation. Conduction. During conduction, heat is transferred by microscopic collisions of particles, atoms, or molecules, and the movement of electrons within a body. The thermal resistance in conduction depends on the thermal conductivity of the material as well as the geometrical parameters. Convection. During convection, the heat is transferred by the movement of fluid. The thermal resistance depends on the convective heat transfer coefficient for the fluid, the temperature profile, and the geometry of the heat exchange surface. However, convection is always accompanied by conduction right at the boundary of the two bodies, which is called the boundary layer. Thus, convection is always conduction plus convection. Radiation. This mode of heat transfer takes place through electromagnetic radiation. It depends on the temperatures, geometry, orientation, and the radiative properties of the heat exchanging bodies like emissivity. Inside a boiler, the first pass, in other words, the furnace section, has radiation as the dominant mode of heat transfer, whereas in the second and third passes, conduction plus convection plays the dominant role. Lastly, understanding steam generation inside a boiler requires us to understand different regimes of boiling. We can look at boiling as the heat transfer process that involves a phase change from liquid to vapor state. It is possible only when the temperature of the surface, Ts, exceeds the saturation temperature corresponding to the water pressure, Tsat. Depending on the bulk fluid motion, boiling is classified as pool boiling or flow boiling. In pool boiling, the fluid is stationary and any motion of the fluid is due to natural convection currents and the motion of the bubbles due to buoyancy. Boiling inside a fire tube boiler is an example of pool boiling. In flow boiling, the fluid is forced to move in or over a heated pipe by external means such as a pump. Thus, flow boiling is always accompanied by forced convection effects. This is the case for water tube boilers like the ones used in power plants. In pool boiling, the process depends on the temperature difference between the hot surface and the temperature of boiling, which is called the excess temperature.